time on this. This is stuff from review from Algebra 1, but I did throw this in on the review, and it's on the test, so this is like free points, really. If I want to plot this ordered pair, which I did, it's right there. Okay, so that ordered pair. In which quadrant or on which axis does the point lie? Quadrant 2. Now, how do we, just quick review here, how do we organize the quadrants? Let's put phones away, please. Shouldn't see any phones out. Put them completely away. Shouldn't see them on desks. Put that away. Put that away. No earbuds. How do we organize the quadrants? Counterclockwise. Good. And they start, good. So they start here. So that's quadrant. That's bad color. Let's see. Let's go there. So there's quadrant 1. There's quadrant 2, 3, and 4, right? Okay, and if you need a review on that, I mean, it's right out of the textbook too. So this is obviously in quadrant 2, isn't it? Okay, give me thumbs. We good on all that? Okay, next. How would we check this? Is -216 or the ordered pair 9, -18 a solution of this equation? What do you do to check? Plug them in, right? No big deal. So we would just plug them in. Let's see, and we could use Desmos for this, right, if you want to. I mean, you have Desmos Scientific the whole way through. There's another question coming up maybe where we'll pull Desmos up and actually use it, but we could very easily here too. So if I plug -2 in for x, does this work? Do I get 16 equals 3 times -2 plus 2? Give me thumbs on that. Does that work? Thumbs up or down? Is that a true statement? That is false, isn't it? The y value of 16 is not equal to 3 times -2 plus 2. So this one is no. And then we go down here and try that again with this solution. We're going to use the same equation, right? So y is becoming -18. X is becoming 9. Let's see, 3 times 9 plus 2. Okay, does that work? 3 times 9, that doesn't work either, does it? Okay. So those were both no's. Okay. Okay, domain and range stuff, going clear back to the beginning of the unit. What's the domain of this relation that's given to us as a set of ordered pairs? Okay, good. And we want to put those in numerical order, which you did, right? So we've got the domain is going to be all the x values. Notice we don't write the 7 twice. We only write just the elements of the domain. We don't have to write them multiple times. We just want to know which numbers appear in the domain and put them in order. So there it is. What's the range? Yeah, we're going to do the same thing only for the y values, right? We got to put those in order. So which one's going to come first? -1. Oh, they didn't put them in order. How about that? Okay, well, we're really supposed to. 2, -1. What's next? 6, and that's it, right? And those really should be in order, but it didn't tell you to. So I guess that's, if they want them in order, they'll tell you to put them in order. Okay. Is this relation a function? What do you think? Thumbs up or down? Thumbs down, right. How come? What's the part that tells us no, this is not a function? Where does it flunk the function test? 7. Yeah, there you go. Notice that 7 shows up twice, right? So the input value of 7 has more than one output, and that violates our rule, right? Our rule for a function is each input only has one output, and the input 7 has multiple outputs. So the answer is no. Okay, how about this guy? This time they're giving us a graph, and we have to pick out the domain and the range and determine if it's a function. So of those choices, what is the domain? And really, we don't necessarily need to limit ourselves to those choices, but what is the domain? What's the set of all the x values that are graphed? They span from what number to what number? Yeah, look at that. The furthest to the left, if an ant's walking on this function, the furthest left the ant could ever go would be at a place where he's got an x coordinate of -3, right? The furthest right he could ever go is +3. Now, it looks like he's going to keep doing this forever, but he's always just kind of walking back and forth horizontally between -3 and 3, right? So our answer there is pretty clearly x is greater than or equal to -3 and less than or equal to 3. Okay, what about the range, the y values? What are the y values the ant could walk on this function? All reals, yeah, it just goes forever upwards and forever downwards. And so the range is all reals. Okay, is the graph a function? Definitely not. How do you know so quickly it's not a function? Okay, it fails the vertical line test. Yeah, if we graph a vertical line, the vertical line intersects the graph in more than one place. So no, it definitely flunks the vertical line test. Good. Okay, how we doing? Give me 1 to 5 on all this stuff so far. How we doing? Okay. So how about this? If we wanted to evaluate this function, I know we probably don't need Desmos, but let's just quickly, I'm going to show you one more time on Desmos how you could use Desmos Scientifics. That's all you get on this test, but that's enough. Okay, what would I enter here in Desmos Scientific if I want to use that tool to evaluate the function? This is like legally cheating. I mean, it's a tool I want you to know how to use, but man, it makes this easy. What do? Yeah, enter the function f of x equals 2x squared, 2x squared minus 8, and then what do? Yeah, just evaluate, right? I'm just going to go f of -5, and there's my answer. Okay, so what's that tell us? Tells us f of -5 equals 42. Okay, everybody, give me a little feedback here. 1 to 5 on all that. Need to see feedback. You can be sneaky about it, but I want to get feedback from everybody. How we doing? Okay. All right. Okay, how about this one? Use the graph of the function to write the corresponding ordered pair. Do you even need the graph on this? Answer is no. You don't even need the graph. You could, but you don't need it. If you're trying to write an ordered pair that goes with this statement right here, that tells you everything you need to know, doesn't it? An ordered pair, what's going there? Input or output? Input, yeah. So that's my x coordinate, and what's going there? Output. Well, what's the input of that statement? What's the input number? The input's 3? What's the input in that statement? Is 2, right? The input is what we're plugging into the function. Okay, so the input 2 goes there. What's the output? 3, yeah, that's what the function is spitting out, right? Remember, in is what you're plugging into the function. Out is what the function is spitting out. The function is spitting out the 3. So there's my ordered pair, 2, 3. Now, could you use the graph? Sure. It's right there. There's the ordered pair with coordinates 2, 3. Okay. But you don't need to. It's all right there. Okay. Okay, how about this one? Find, given this function, or this relation, I guess we don't even know if it's function, but given this relation f, what is f of 7? So what's the, in this statement, what's the input number? 7, right? So we're inputting 7. Oops. And the output then, what is the output when we input 7? It tells us up there in those ordered pairs. 3. Tells us right here, doesn't it? If we input 7, we output 3. Okay, give me 1 to 5. Questions? Any questions so far? Okay. Okay, this is one that I think definitely want to hit this one. It seemed like there were some issues on this one on the homework and on the review. If I look at it, for some reason, this one seems to be causing a little more trouble. So use the graph of the function to find all values of x such that f of x equals 5. Okay, so now what's that telling us? F of x equals 5. Is that an input or an output? Output. Is it an x or a y value? Y value. Remember, f of x is just a fancy name for y. So we want all the places where y is equal to 5. Okay, well, y equals 5 is right there, isn't it? That's the line at y equals 5. So we want to find all the places on our graph that have that y value, which would just be where they intersect the line y equals 5. Okay. Do you have to graph the line y equals 5? No, not really. You could just do that in your head, but it's a convenient way to think about this one. So we can see there are 2 places where that happens, right there and right there. Okay, so we're trying to find all values of x. So what would the x values be? Yeah, look at that. There's an x value at 0, and there's an x value at 2, right? So we get 2 of them, 0 and 2. Okay? Give me thumbs. How we doing? Up, down, sideways. How we doing on that? Okay? This is really a big deal. We're going to do a lot of this like next unit. Next unit when we're going to start to solve equations graphically when we can. And an easy way to solve equations graphically a lot of times is just to set 2 equations equal to each other and look for intersections, right? We'll get into that next unit more and more. Okay, how about this one? They give us a function, v of x equals x cubed, and that's used to find the volume of a cube. So v for volume, a cube with side length x. Find the volume of a cube whose side is 12 centimeters. How would I use that function to find the volume? 12 cubed. Yeah, I'm just plugging 12 into the function. And so we're getting v of 12 is just going to equal 12 cubed, which is just 1,728. It's a big number. Okay, but that's how you do it. And again, you'd have Desmos, so you could even just type in v of x equals x cubed and evaluate v of 12 in Desmos. I'm going to rewrite this equation in slope-intercept form. So first of all, remind me, what is slope-intercept form? Oh man, you guys are on top of this. Y equals mx plus b. Okay, so I've got to get that equation, and let me rewrite the equation. I've got to get the equation 5x plus y plus 3 equals 0 into that form. What are the algebra steps I'd have to do to get it into slope-intercept form? Okay, subtract 5x. Good, that's one thing. What else? Subtract 3, and I got to do the same thing to both sides, don't I? Subtract 5x and subtract 3. And perfect. And the whole point of that was to isolate the y, wasn't it? To put a linear equation into slope-intercept form really just means you're going to isolate the y and then simplify the other side, right? So what do we get then? We canceled the x's on the left side. We moved them to the right. We moved the 3 to the right. We get the y by itself is equal to 0 minus 5x minus 3. Isn't that just minus 5x minus 3? Anybody agree? Okay. Good. So now we got it into the correct form. Once it's in that form, it's really easy to work with and graph, right? That's the whole point of slope-intercept form. Just by looking at that equation and comparing it to slope-intercept form, what's the value of the slope? What's the slope? Well, I mean, compare those. What value would I have to plug in for m to get that? -5, right? The slope, when it's in slope-intercept form, the slope is always going to be the number in front of x. So the slope is -5. What's the y-intercept? -3, because the y-intercept is just the constant that we're adding at the end. Okay, and then it wants us to use the slope and the y-intercept to graph the line. So where do I start with my graph? -3 on the y-axis, good. So there's our first point, -3. And then it wants us to use slope. Well, you told me that slope was -5. How would I write that as a fraction? Over 1. Okay, that helps us make a slope triangle, doesn't it? So what am I going to do to get to my second point from my first point then? Good. I'm going to rise by -5, which means I'm going down 5, and I'm running by 1. So 1 to the right. That gives me another point. And now all I have to do is just connect and extend. And that's a terrible line, but you get the idea, right? The graphing tool does all that part for you. You just got to pick the two points. Okay, give me thumbs. Man, you guys are on top of this. Quick one here. This is a super easy one, but you got to know this relationship. If a line has a slope of -8/9, then any parallel line, that's really important, any parallel line would have a slope of -8/9. They have to be the same, right? Parallel lines have equal slopes. How about any perpendicular line? What's that going to be? What do you have to do to get, remember we got to do something with our hands to do that one. That's how we remind ourselves. Perpendicular lines have opposite, they're opposite, so we switch the sign, flip the fraction, opposite reciprocals. So it's got to be positive instead of negative, and we got to flip the fraction and get 9/8. There it is. Okay? Let's apply that. How about a situation like this? Decide whether the pairs of lines shown is that pair of lines, are they parallel, perpendicular, or neither? Okay, you want to say perpendicular, right? Okay, but it's neither. How come? Because although we did flip the fraction, what didn't we do that we'd have to make them perpendicular? We didn't switch the sign. They're both positive. So this would actually be a case where it's neither. Oops. Let's undo that. Okay. Make sense? Okay. Okay, what's the equation of this horizontal line? How do you always name a horizontal line? It always starts out, every single one of them, with what? Y equals. Good. Right, so we know if it's horizontal, it's a horizontal line, it's always going to be y equals. And what is y equal to? 7. Okay, how come again? Because every single point on that line has a y coordinate of 7. X could be anything, right? But y has to be 7. Give me thumbs on that one. How we doing? Okay. Last one for today. We'll just wrap this up tomorrow. So find the x and y intercepts of this equation, and then we're going to graph it. Okay, so how do I find, if this is the equation I'm starting with, let's make this a little bigger. How do we find the x-intercept? What has to happen at the x-intercept? There's something really important that happens at every single x-intercept. What's the y-coordinate for every x-intercept possible? What's the y-coordinate of every single x-intercept? 0. Has to be, right? So then our trick is, remember, we can just do this. Remember this great trick, this cover-up trick. If I want to find the x-intercept, I'm just going to cover up the y term and solve. And it's easy, right? If I cover up the y term, 2x equals 8, what's x? 4. Yeah. Couldn't be easier, right? So, oops, oh boy, of course. Of course.